Gautam, is my voice audible?
Yes,
Hello.
yes.
Yes.
Good evening, everyone. Hope you are sound and safe at home. I, Harshit, convener CSI MVSR, take immense pleasure to welcome you all to week 2 of webinars. While we head into the session on the Internet of Things, I will tell you a few rules that has to be followed by every participant for smooth ongoing of the session. I hope everyone follows that. Rule number one, everyone should mute their microphones. No one should present or cast their screen, or no one should turn on the video. No multiple chances to join the webinar. Once you quit, you will not be allowed to join again. You can turn on your mic only if speaker gives a chance to ask doubts. If any mischief or disturbance is found by any participant, will be removed immediately from the session without prior intimation. All the problems should be messaged to the event coordinators along with the screenshot. Today's event coordinators are Sujita and Ritvika. You can find their numbers in the mail that we have sent to you. Thank you. Now I request Sujita to introduce about the speaker.
Yeah, am I audible?
Yes. Yes.
Good evening, everyone. Welcome to today's webinar on IoT by Mr. T.Sujanavan. I am Sujita, CSI MVSR Student Branch Coordinator. I take this opportunity to welcome you to the 9th webinar in the webinar series organized by CSI MVSR Student Branch. Let me introduce you to our speaker with a short bio. Mr. T.Sujanavanan sir has graduated Bachelor of Engineering in Information Technology and was awarded by OSMANIA University with a distinction. He completed his Master of Technology, specialized in software engineering. He was awarded a distinction by Jawaharlal Nehru Technological University, Hyderabad, and also ISTE Gold Medal in December 2011. Sir is currently working as the Assistant Professor in the Computer Science Department, MVSR Engineering College, since 2011, and also is pursuing Ph.D. as a part-time research scholar in the domain of IoT infrastructure area in the Computer Science Department, OSMANIA University, since August 2018. Thank you, sir, for being with us today. Now, I request Mr. T.Sujanavan, sir, to continue the session.
Yeah, am I audible? Is
Yes,
my
sir.
voice clear or is it breaking?
It's clear, sir.
It is clear, sir.
Everything clear, right? I don't think my voice is breaking. Okay, thank you. Can I start my presentation?
Yes, sir.
Yeah, thank you. Yeah. Okay, is my screen visible?
Yes, sir.
Is my screen visible?
Yes, sir.
I hope my presentation is also visible. So good evening, one and all. Before I start, let me tell you that today's session is going to be the very basics of IoT. Okay, the very fundamental basics of IoT. Okay, this is for the beginners. If you have already gone through the introduction of IoT or fundamentals of IoT, I guess this session you might already know. Okay. Of course, I'll give you a different approach, a very basic fundamental approach for students to understand. So, yeah. So I'm Sujanavan. Okay, I'm working as an assistant professor in CSED department at MVSR Engineering College. You can contact me on this mail. I'm also a part-time Ph.D. scholar in the domain of IoT, registered in the Faculty of Engineering, Computer Science and Engineering Department in OSMANIA University. I have a hobby project, small hobby project, which is called Sushi Linux, which my college and some of my students are using. It's a Debian-based or Ubuntu-based Linux OS distribution. And for today's session, I like to special thanks to Cisco Networking Academy and EDU Skills. Yeah, so you need to remember this person's name, which is important. He is the first person who has invented something called as an internet toaster. Many of you know, but this is for the people who don't know anything about IoT. So he used to work in a company called P&G. Everyone knows this company, Procter and Gamble, very famous company. P&G, they have many products. So during a tea break, his manager asked, can you control this toaster over the internet? He said yes. And he created this internet toaster, okay, using a protocol called SNMP. You can Google it out. So this was done in 1990. Okay, this was done long ago in 1990. But the problem is, he was the father who didn't name his child. It was also exhibited, but he was a father who didn't name his child. Okay, so please remember this person. Okay, John Romke. Okay, so in 1999, there was a person called Kevin Ashton. Okay, now please remember that he invented the term. Okay, the term, please understand, term means a meaningful word or meaningful words called as Internet of Things. Okay, that is how he became popular. Okay, so he is the inventor of the term. So frankly speaking, he is the father who named the child. Okay, so please try to understand. I don't want to make it complex, but just understand these two people are there. Okay, Romke and Mr. Kevin. Okay, so what is IoT? Now the definition itself, I mean, not the definition, the full form of IoT itself is a big confusion. Okay, of course, if you ask any person, any student or any kid, he'll tell IoT is Internet of Things. Very good. But is it always Internet of Things? I don't think so. Out of my research and my study, I didn't see IoT as Internet of Things. Okay. Now there are some other people who say it is called intranet of things. Intranet. Okay, intranet of things. IoT is intranet of things. Okay, that means there's a local network. Your organization owns a network, and you have many components in your organization, like a factory, and different hardware need to talk to each other to synchronize, so that the product line, manufacturing line, does the job well. So that is intranet of things. Okay, or simply to say some things at home communicate among each other. That's Internet of Things. So Internet of Things, intranet of things. But it is actually, what I think is something called as integration of things. Okay, it is not. It could be Internet of Things. It could be intranet of things. But what are we trying to do here? We are trying to integrate. Okay, we are trying to integrate different things. Okay, so I think IoT should be in a meaning of integration of things. But there's a confusion again. It was good that my session is today, because if it used to be the first session, I would get a lot of questions, something like, what do you mean by cloud? Okay, and what do you mean by data analytics? Okay, so please let me tell you something. IoT is not only integration of things, but also it is integration of technologies. Okay, so please try to understand. IoT is a kind of, it is integrating technologies. You have seen image processing. Yes, we'll be using image processing. Okay, but please, I'm not doing image processing. Okay, please try to understand. I'm integrating technologies. We have cloud. Yesterday you have seen computer networks. Okay, so we are going to borrow, or we are going to integrate all these technologies. That is what I think is IoT. So let's see step by step, what do you mean by Internet of Things? So let's start with the words itself, like Internet of and things. So internet, nowadays everyone says that internet means cloud. Okay, it's somewhere, you like, that's internet. Okay, people think that, not think, it is. Okay, nowadays internet is cloud. Okay, next we have things. What do you mean by things? Things are any physical entity. You name any physical entity, it becomes a thing in IoT. Yeah, and this of also has a meaning. Please understand, this of is connecting these two words, right? I should say not two words, but two worlds. This world and this world. Okay, where this is the physical entities are the physical world, and our internet is, of course, you know, it is a logical world. So of here has a special meaning, which is connectivity. Okay, so what do you mean by cloud? So let us come a level detail. What do you mean by cloud? So of course, cloud means you need to have some physical hardware. Very good. So you need to have the server. You need to have some data store, because you have seen, right? You have seen all the sessions. They are saying that data is growing a lot. So data store. Then you need to perform some analysis, some processing, and some visualization you need to show to the user. Okay, so this is all the part of the cloud. That is what happening on the cloud. Okay, very good. So your machine learning, AI, whatever you think, data science. Okay, everything I push it on this side. Okay, next come to physical entities. Now physical entities could be a simple bulb or a fan or a door. Very good. It could also be your smartwatch and smartphone. It could also be electricity, water, and gas, if you have a monitoring device attached to it. It could also be a car, bus, train, ship, anything, any physical entity, anything in the world. If you see something right in front of you, right now, if you see something right in front of you, tomorrow it could become a part of IoT. Okay. Next, connectivity. So connectivity, the things which are involved in connectivity, we have hubs, switches. Let's go a bit deep, means a bit higher level devices. We have a router, we have a broker, we have a bridge, and let us go a little bit higher. We have a gateway, a bit higher, who's providing you internet, the internet service provider. Okay, now this all clubbed together, okay, becomes your Internet of Things. So in between, like if you want all these things to work together, it's a problem. Okay, so we need something called some protocols. Okay, these are some popular protocols being used. People are using HTTP over TCP, MQTT over TCP, CoAP, which is under working over UDP. Now it depends, like what combination you want. It's based on reliability, or you want lightweight. Okay. Now some people have a doubt, like I've heard that even first years are here and non-CSE students are here. So what do you mean by a protocol? It's nothing special. Okay, protocol is a set of rules. Okay, so that different things, different entities can cooperate together to exchange information. Okay, if you don't understand, absolutely no problem. You can just think protocols as traffic rules and road signs. Yes, of course. Okay, so protocols are rules and regulations so that everything goes fine. Okay, next. So let us start step by step. Okay, let us get into the physical content. So imagine I take a bulb. Okay, imagine that there is a bulb. Okay, now sir, why should I imagine a bulb? Okay, no problem. You can imagine anything over here. Okay, in the place of the bulb, that's up to you. I just took a bulb. Okay, I just took a bulb. I just chose a bulb. Okay, whatever you want to think in that place of the bulb, you can think. Okay, next, I'll take a sensor. Now, don't ask me, sir, what is that sensor? There are n number of sensors and actuators. You can choose any sensor and actuator. There are different types of sensors and actuators. Of course, we are not building it. Someone else is building it. Okay, we are just trying to integrate them. So sensors and actuators. Okay, now these three things are the combinations of something having sensors and actuators was there from long ago. Not only now, it was there from long ago. Now, what do we call it? Okay, we call it as control systems. It was there from long ago. Okay, now what are the examples of control systems? Yes, this is the first example. You get it in Koti, like in Hyderabad, Koti. Okay, so it is control systems. Very popular. Everyone uses it at home. It is a part of control systems. Okay, so you have a tank overflow alarm, or you have a washing machine, or an old air conditioner. Okay, so all these come as a part of control systems. Okay, so they have a sensor, they have an actuator. Okay, so it could also be a motion sensor alarm. You know, like in banks and jewelry shops at night, they switch on this and they leave, and someone tries to come in, the alarm switches on. Okay, so let's take a small demo. Like, it is a lockdown time, and if you want to work at home, how do you work with these things? Okay, you don't have anything at home and you want to work. So the best things are, there are some simulators. So I'm going to use something called as a Cisco packet tracer. So this is Cisco packet tracer. So this simulator is going to help us simulate our example. Okay. Yeah. I'm just using a magnifier because some icons in Cisco packet tracer are not visible. Some icons over here are not visible, so I'm using a magnifier. Okay, so this is Cisco packet tracer. This white space is where we are going to simulate the environment. Okay, and this Cisco packet tracer has the capability of simulating an entire city. Okay, or cities also. Okay, so I'm just showing a small example. So there are some things over here which you can't see, so I'll just magnify. Okay, I'll magnify a bit more. Yeah. So these are all the different types of categories we have in Cisco packet tracer. So I'm choosing something called components. Okay, of course, there are something called network devices. Then you have something called end devices. Network devices are like we already discussed, right? Hubs, switches, gateways, routers, all those come into network devices. Then you have end devices. End devices are your computers, laptops, servers, mobile phones, everything comes under end devices. Then we have components. So here we have different types of components. We have a MCU, which is called as a microcontroller unit. So if you have seen someone saying someone is using Arduino, okay, as a microcontroller, okay, this is that that module over here available logically. Okay, then you have an SBC. SBC is a single board computer. If you have heard something about Raspberry Pi, some buzzword about Raspberry Pi or Intel Edison or BeagleBoard, okay, they come into this category of small single board computers, SBC. Okay, of course, we are not using them right now because we are doing an example of control systems. I'm just making you familiar. So in these components, the first thing you have is boards, which you have seen. Next, you have actuators, different types of actuators. Okay, so you just touch something, you'll be seeing over here the name. Okay, right? And then we have sensors. Okay, different types of sensors. Okay, I just touch something and you can see this is a smoke sensor, this is a sound sensor, this is a photo sensor. I'll be using a motion sensor right now. So I hope it is visible. I'm just closing the magnifier. Yes. Now I'm going to take a motion sensor. Okay, I'm going to take a motion sensor. This is the environment. I just drag and drop it. Then I take an actuator. So I need an alarm. I'm taking an alarm from here, and then I dropped it over here. Okay. Now I need to connect them both. I need some wire, some connectivity. So I'll go to the next category, which is called connections. I click on it. Then there is a separate, there's a separate connection type, which is called IoT custom cable. I select it. Then I select this motion sensor, select the port. There's a particular port. Okay, D stands for digital. Okay, then I select the alarm. Here also D stands for digital. Okay, now it is connected. Now how does it work? Because it is a environment which is inside the computer, logical, how does it work? So nothing to worry, you can just open this, double click this motion sensor, and then you'll get the description. What do you mean by a motion sensor in this environment, simulation environment? How does it work? Okay, when does it get activated? Okay, so here a person cannot go into the computer, so this mouse is going to simulate. So this is a lockdown time, right? So you can't work with physical devices, go outside and purchase. We don't know how safe it is. So this mouse is going to become the person inside. Now, how do I interact? So I'm going to use Alt and mouse. So normally, if my mouse is moving in front of this sensor, the alarm doesn't glow because it is the regular computer mouse. Okay. Once I catch Alt and then move my mouse, then this mouse will become a person. Okay. And then this alarm will glow. Okay. So please see this alarm. Please be seeing this alarm and the mouse. Okay. So now I'm catching Alt. Now I'm trying to pass in front of the motion sensor. And you see that the alarm has glowed. Right? So this is how your simulation environment, one of the simulator in IoT works. Okay. Cisco Packet Tracer is very good. A lot of people have kept a lot of effort in it. Okay. So this is the example of control systems. Okay. So let me go back to my slide. Okay. So that is what is control systems. It was there from long ago. Okay. Now, the next thing is I'll add some intelligence. I'll add an intelligence to this control systems. Okay. That intelligence is provided by a microcontroller or the microprocessor. It's up to you. Okay. How you program. Okay. Now this becomes a thing. So you'll have an actuator, you'll have a sensor, and you'll have a microcontroller, and of course, you'll have housing so that everything looks neat. Okay, so this becomes an anatomy of a thing, the basic thing anatomy. Okay, now what is this actually? It is actually embedded systems. Okay, this is actually embedded systems. This is all a part of embedded systems. Okay, now where have you seen embedded systems? Yes, you have seen MP3 players, simple MP3 players or complex MP3 players. You have also seen video game consoles. You have also seen digital cameras. These are all embedded systems. The DVD players, of course, nowadays we don't use them. Everything is smart TVs. Technology is advancing. And of course, your smartphones and smart watches also become a part of embedded systems. Okay, so this embedded systems is becoming the anatomy of a thing. Okay, the anatomy of the leaf node. Okay, leaf node is the end node in a tree. Okay, the molecule in IoT. Okay, so that's embedded systems. So let's see a small example how embedded systems works in the simulator. So normally people who have heard about Arduino, there is a first program in Arduino which is very popular, which is called a blinking LED. So we'll be seeing this example in Cisco Packet Tracer. So now I'm going to take a microcontroller. Okay, so I'll just choose a microcontroller. I kept it over here. Now I need an LED. I'll go to actuators. LED is an actuator. So LED, I drop it over here. Now I need to connect them both. Okay, now I take connections and then I choose the IoT custom cable. Now once you click on this microcontroller unit, it has many ports. you have to select the particular port which you want to use in your program. Okay, so here I have many ports. There are A stands for analog ports and D stands for digital ports. So you need to select, okay, which port you want to use. Okay, the port number also. Okay, because you will be using it in your program. Okay, and of course, it's better you know about your sensor or actuator. If it is digital, then you'll be using digital. If it is analog, you'll be using an analog port. Okay, so I'm selecting D1 because in the program it is D1. I've used D1, and then you select this LED. Okay, and of course, LED side you don't need to bother. Okay, you only need to bother about the port number connected on the microcontroller unit. Now, once I open this microcontroller, now I need to program it, right? I need to program this microcontroller unit. So how do I program? You just need to double click it. So in packet tracer, you'll get this description about it. There's no description over here. You can go to programming, and by default in Cisco packet tracer, there is a blink program. Of course, a Cisco packet tracer gives you a lot of programs. Whatever actuators and sensors are there, they have given examples of each of them and some combinations in their examples. If you go to file, examples, yes, samples, it's called samples, you can find a lot of examples in it already done by Cisco packet tracer. This is the basic one, which is blinking and LED. So once I open this, I get my script. The script given is 99%, not 99, 90% compatible with the Arduino environment. Okay, so we have some functions called setup where I initialize, and loop, because embedded systems need to run in an infinite loop. Okay, so I have two functions. So this code is 90% compatible. Why I say 90% means when you have bigger programs, the compatibility decreases. Okay, yeah. So this is called pin mode. I told you I'm using digital port 1. So that's why I've written, I'm defining port 1 as output, because LED is the output to the microcontroller unit. LED is an actuator. That's why I'm using output. Then I just print this to my console. Okay, console is over here. If you have worked with Arduino, it is called as serial monitor. Okay, it will print on the serial monitor. That's why it's called serial over here. For me, it will just print all the serial outputs over here. This will become my serial monitor. Okay. So this prints only once because it is initialized only once when you power it up. Then you have a loop function which runs forever. Now I have defined digital port 1 as output. So that is initialization. Now, when I want to switch it on, when I want to switch it off, you need to write some code. So that is what is digital write function. So digital write function, of course, for digital type of devices, we use digital write to send the command. Okay. Now, which port? Port number 1, and what should happen? This is high. High means you're going to send a high voltage. Okay. You're going to send a high voltage. Okay. Now, what will happen? The LED will glow. Okay. Next, when you give a delay for 1 second, this glowing of the LED will sustain. Then after some time, you're going to write digital write, then port number 1 means D1. If it is analog, you have to mention A. If it is analog, you have to give A. Okay. If it's digital, it's not required in Cisco packets. Now, low means cut off the voltage. Okay. Now that is when the LED will not glow. LED will not go, and it will wait for 500 milliseconds. This 500 is milliseconds. Imagine it's half a second. So I'm making it as a second. Now, once you click on this run over here, you see a run over here. Once you click on this run, okay, you know what's going to happen? Now, this LED will start glowing. So just observe this LED. Once I click this run, so I just click on run, and now you see that the LED is glowing. So this is the importance of this Cisco packet tracer simulator environment. Okay, so it's a good one, a good environment. So this is an example of embedded systems, a very small example. not a very huge example, it's a very small example. It is the first program which you do normally do when you enter into this world of IoT. Okay. Yeah. So next, once you attach a home Wi-Fi router or your router at home, what is going to happen? You are going to create a network with a huge lot of such things. So don't think that this is just a bulb. So imagine that there are many bulbs and many fans and many appliances at home which are getting connected to this router, and you can do wonders. Okay. So if you stop over here, this is called as intranet of things. Intranet of things. So it is happening something in your own network. Okay, in a confined network. Okay, a network which you own or an organization owns. Now that becomes intranet of things. Okay. Now what are some examples? So some examples are like home automation, office automation, and we have building automation. Okay. And you also have warehouse space management and production line monitoring. Okay. Why do people opt for intranet of things? The first thing is security. You don't want some hacker to sit somewhere in some other country and operate your devices. Okay. So you want a confined network. No one gets in. It is not connected to external world. Okay. That is one reason. Okay, that is one reason. Okay, so that is intranet of things. Okay, so let's see a live demo of a future home. How does a future home look like? Okay, in Cisco Packet Tracer. Okay, so future home, right? So let me go to end devices. I have end devices over here. We have already seen. Then you have home. If you are on a mobile, you can pinch zoom. Okay, if you are on a desktop, I hope it is visible. Okay, just click on home. Yes, you have all these devices. These are not regular devices. These are all IoT devices. So I'll take a fan. See, I'm taking a fan. I'll drop it over here. Now it is called IoT fan. Okay. Now let me take a garage door. I'm just choosing a garage door. And let me see another different component. Okay, I'll take this last component. Window. I'm taking a window. These are not regular things. These are all, what do you call? IoT window, IoT garage door, IoT fan. Okay. Now, if you want to integrate all these, you need a router at home, right? Now, it is not called as a router. Okay. It is somewhat more intelligent. It can do more work than a router. We are calling it as a gateway. So here in network devices, first category, you have routers, switches, hubs, and wireless devices. I'm going to wireless devices, and here I have something called as a home gateway. Home gateway. I'm choosing this home gateway and I'm dropping it over here. Yeah. Now the problem is they didn't connect. Why? Because by default in Cisco Packet Tracer, they are on wired network. Now let me change them to wireless network. I'll change all these things to wireless networks. Let me just show you. So I'll just select the fan. Okay, this is the fan. I'll go to advanced. Okay. Now I'll go to IO configuration. Then here in network adapter, I have something called E at the ending, CFE. So FE stands for fast Ethernet. I'm changing it to W, where it becomes wireless. Okay. Now once I change it, observe over here on this side. Yes, now it is connected. Okay. So imagine that you're connecting some things to your home router. Okay, or a gateway. Okay. Next thing I need to do is I need to configure and tell the fan that the IoT server. Okay, the IoT server is the home gateway. Okay, just telling the fan that IoT server is the home gate, so that it will register with the home gate. Okay, next I'll do the same with the window. I'll be a little bit fast because I'll do the same thing. So I'll make it wireless. I'll go to the configuration and then IoT server home gateway. Same thing with the garage door. Advanced. IO configuration, wireless, configuration, IoT server, home gateway. Done. Okay, very good. Now, in future, how do you think you'll interact with these devices? How do you think you'll interact? Of course, most of your answers will be some mobile phone, smartphone. So let me go to end devices over here, and then I'll choose a smart device. Okay, now imagine this is your smartphone. Okay, so this is my smartphone. Okay, now how do you connect to your Wi-Fi? Okay, so just open the smartphone. You'll be going to configuration. Here you'll have wireless. I'll just type over here. SSID is a Wi-Fi name. I'll just type home gateway. Now once I finish typing, wait for a minute, not minute, wait for some time, and yes, you see that it is connected to the home page. Now what do I do with the smartphone? I'll go to the desktop. So these are all some apps. Okay, some apps provided by Cisco Packet Tracer. I'll go to IoT monitor. Okay. Yeah. Now this is the server. So home gateway here is acting as a server. Actually, it is a broker also. I will get to know what is a broker. Okay. So I'll just log in to my server. Okay. So and now I can see all the devices registered with my broker, or you can also tell server, home gateway. Okay. So gateway, I hope you understood that it is a somewhat more complex device, not a regular router. Okay. I can see all this. Okay. Ceiling fan, I can switch it on, off. So this is from the mobile view. Okay. Now if I click on low, observe that this fan's graphical notation will change. Okay. So low means, yeah, it's kind of rotating. High means some graphical symbols. Yeah. Please observe this fan. Yes. I'm clicking on low and high. Yes. You get some notation. Okay. It's a simulation environment. Okay. What do you expect? Just a graphical notation. For the window, observe the window. It is red. Click again, window opens and closes. Yes, opens and closes. Right. Garage door. Yes, you can open the garage door and close. Yes. So this is good. This is very good. This is God. This is happening right now in some places, but we need to expect something more. Right. So when do you do this? Normally, you have a car. I'm just taking a car. Yes, you are coming home in a car. You don't want to get down. So you open your smartphone and you operate your garage door, window, and fan, right? Yeah. But in future, what happens is when your garage door opens, automatically your window and fan will also start without you telling them. Now, how does this happen? Okay. So that is where your home gateway, and there's a protocol called MQTT is going to play a vital role. Please, let me repeat, MQTT. There's a protocol, and this home gateway is going to act as a broker. Yes. So let's see how it's going to happen. So I'll open the smartphone. I'll again go to IoT monitor. Right. I've already logged in, so it doesn't ask me again. Right. So here I'll go to something called conditions. I'm going to something called conditions over here. I'll click it. Okay. Now, whatever I create over here, that is going to be called as a topic. Topic. T-O-P-I-C. Topic. That is what is called as per the regulations of MQTT. Okay. So you create a topic, and things, when you define the condition, okay, things will get published and subscribed to that topic. So let us see how this condition works. How do you create a topic, and how does this publish subscribe work? So you just add a condition, add. I give a name, something like car, or I am home. I just make I am home. Okay. Now I'm going to give a condition. This condition, if, is going to become the publisher, and then is going to become the subscribers. Subscriber or subscribers. Okay. So here, if, what is my garage door? IoT1. 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 That means I come in the car and the garage door opens. Okay. It is true. Then set IoT0, which is a fan, status as high. And another subscriber is going to come here. IoT2 should open. I mean, on is true. That means the window should open. Okay. Now let me just save this condition. Please understand. Let me repeat. This is a topic where here you have the publisher. Your garage door is going to become the publisher, and these fan and window is going to become your subscribers. Okay. So I'm just saving it. So this is your topic. You got the topic over here. Now let me see. Let me go back to home. So this is the topic. Okay. This is your publisher, garage door. These are your subscribers. Okay. MQTT, as per MQTT standards. Okay. Home. Let me just go to home. Now this is my garage door. Now when I click on this garage door, it is going to open. Very good. But when I open this garage door, please observe that the window should open and the fan also should start working. That means what? I am not talking to these things. The things itself are interacting. That is what I said as intranet of things or integration of things. Okay, things start talking to each other. Okay, so just observe this window and fan. I'm about to click this garage door. Okay, I just click it. Yes, and you observe that the garage door has opened and it has published that I have opened and people have subscribed. Fan has subscribed, window has subscribed, and now they are working. Okay, as per that condition. So this is the future home. This is an example of intranet of things using an MQTT protocol. Okay. So that is one demo. So I'll stop over here to take some doubts. Okay. So if you have any doubts, you can please ask. I'll just pause. I'll just pause. Anyone has any doubt can ask. Okay. Can my coordinators tell me, do you see any doubts from the YouTube live session? Cisco Packet Tracer is not open source, sir. You have to register with a Cisco Networking Academy and then you can use it. Yes, Sandeep, you said how to improve security in IoT. Very good. I didn't come to the research areas. And let me tell you something. Security, sorry to say, security is not actually the domain of IoT. Okay, I'm sorry to say again, security is a different domain. Okay, there is a whole lot of things running in security. Okay, yeah. What is MQTT protocol? It's actually MQTT protocol, actually MQTT. Okay, it's a protocol. And what is its full form? You can just Google it out. Can we ask some other questions, please? I have explained about the protocols. I have some more questions. What are the protocols used in this application? Yeah, what are the protocols? There are many protocols. Let me tell you again. I only discussed about MQTT, which is a higher level protocol. Now TCP, there are some underlying layer protocols, which let me tell you frankly, as an IoT person, if you're doing a IoT project, you are not bothered about. Let me tell you. If you are a computer networks person, yesterday we had a computer networks, the specialization of computer networks will bother about it. I'm sorry about that. Yeah. Instead of MQTT, can we use, I guess, this SMQTT stands for secure. Of course, you can use Sandeep. Yeah, Sandeep is an advanced IoT person, I guess. That's why he posted a question about how to improve security and use SMQTT protocol. Very good. Thank you. Any other questions, or I can go back to my session? Yeah, coordinators, are there any questions from the YouTube live session? Yeah.
No.
There's a person called Sham Kiran asking a question. How to select which connection suits with my device? Now I don't know whether to correct you. Is it device or sensor and actuator? If it is sensor actuator, you need to know the type, analog, digital. Okay. If it is D to D communication, you should know I want to connect wired. Acha, you want device to device communication, that too wired. Yeah, you have a lot of options, which is in computer networks. I'm sorry, I told you in the beginning, we are not doing computer networks job here. We are only trying to integrate. Okay. So of course you can have optical fiber if you want. You can have Ethernet. Your TV cable also is also the same kind of wired connection. Okay. You can use a nowadays there's something called, they're using current wires also. You can pass data through current wires. There's a research going on. Yeah. Any more doubts from the live session? Okay, then I'll continue my presentation. Yes, Harshit, I hope you can see this chat by Jyoti D. Gopal in the chat. Any coordinator can see, because of COVID situation, students are facing problem to procure hardware items. Kindly share the recorded version of the session. Yeah, of course, I guess it is going to be provided. Please reply to it. I'll continue my presentation. Yeah. Is my screen visible? My coordinators are there. My screen is visible.
Yes, sir.
Yes, sir, it is visible.
Yeah, thank you, thank you. So let me continue. So we finished till intranet, then we took a gap. Okay, so we reached one kind of IoT. Now imagine you get a IS, internet service provider, connecting to your home, and you connect to the cloud. Now what is cloud? So there should be something physical behind the cloud, that is a server. So somewhere physically your data is being stored. Okay, now this complete formation of all the devices, imagine there are a number of devices and they talk over this, okay, to each other. Human is not involved. Okay, human might not be involved, human might be involved. Now that becomes our topic. Okay, so that is internet of things. Okay, now that becomes internet of things. Okay, things talking to each other over the internet. Okay, human might be involved or might not be involved. Let me tell you that. Okay, now, yeah, all of you know this, right? We are all huge fans. Yes, we all know this, right? So here, please try to understand, sir, human is not involved. You said human might not be involved. Okay, so please try to understand that this device via the internet is accessing this device. Okay, frankly speaking, this device is listening to a server to which this device is talking. Okay, now there is a human, of course, to operate this thing. This thing, please let me tell you, this thing communicating with a server, which is a thing, that communicating with this AC, this is a thing. See, I guess nowadays, I guess everyone wants to see. This is a very popular example. That's why I took it. Nothing. I'm not broadcasting anything. Okay. Yeah. So that is what is Internet of Things. This is a very small example. Very small example. Okay. Now we have seen control systems. We have seen embedded systems. Yes. So control systems is hardware, that is sensors and actuators. Embedded systems is with the control systems. With this control systems, you add one microcontroller or microprocessor, make it a little bit intelligent. Okay, where you can work with instructions. Okay. Now, what is Internet of Things? You take this embedded systems. You take this embedded systems and attach networking to it. Okay, attach a network to it so that multiple things can talk to each other. Things can talk to each other. Okay, so that becomes Internet of Things. Now you attach this Internet of Things to the cloud. Now that is what we are saying, that in modern days it is Internet of Things. Okay. Now simply it could be an internet controlled AC, as we have already seen, but it could be more complex, like a GDAX, which is called as a Global Disaster Alerting Coordination System. Okay. So these are some examples for you. Okay. But GDAX is something more bigger. I'll tell you, this GDAX is more than Internet of Things. Okay. But it comes from Internet of Things, but GDEX is something bigger. I'll tell you what. Yeah, so we have a demo, but I guess the time is running out. Can I show the demo? I request the coordinators to
Yes, sir. Please show the demo,
reply.
sir.
Can I show the demo? Do I have time?
Yes, sir. We have time, sir.
Yeah, so this
40
is
minutes
one,
more.
this is the demo. Yeah, so yeah, thank you. So this is an internet control LED which everyone wants to see. Okay, whenever they get into your IoT, Arduinos and Raspberry Pis, everyone wants to do this internet control LED. So something you do on internet and it works on your device. So for that, let me just, of course, go back to my Cisco packet tracer. I hope my entire screen is being presented. Yes, coordinators, I guess my entire screen is presented, right?
Yes, sir.
I think yes.
Yes, sir.
Yeah. Yeah. So now let me first take a component. Oh, sorry. I'll take a microcontroller unit. So imagine this is Arduino. Okay. Of course, I'll take this LED again. Okay. Simple example. I connect them. You know how to connect, right? Very easy. Take an IoT custom cable. Select the port. Sir, we have seen this very good, right? Now let's, for 5 minutes, let's be active. Okay, all of you be active. So this microcontroller unit, okay, now it has some programming. Yes. Now I need to change this programming. I need to change this programming so that it can talk to the internet. Okay. Now I have some code already with me. Yeah, this is my GitLab account. Yeah, you can just type Sujanavan, you'll find it. So let me go back to Cisco packet tracer and I pasted the code. What is in this code? Of course, on and off is there. Don't worry, nothing special is in this code. What I need is a URL. It is Internet of Things, right? I want to switch on that LED from the internet, right? So I need a URL, a particular URL where I can publish, okay, or where this microcontroller will go and ask, what should I do? Okay. Now I'm using a HTTP protocol. Okay. Please understand, I'm using a HTTP protocol right now. Okay. So this is a small variable, okay, which I'm declaring it as a HTTP client. Okay. So this microcontroller is going to become a client. Okay. I'll go to this URL and ask what to do. Okay. Now, if I get a return as data is greater than 0, that means something on the server, on the cloud says that it is a 0, then I will switch on the LED. Yes, 1 comma high is what? Switching on the LED. Okay. Now, if it is greater than 0, it is going to become high. High means what? Switching on the LED. Or else, if it is equal to 0 or less than 0, it is going to become what? Yeah, low. That means what? LED switch off. Okay. So now let me just change this delay. It's 15-second delay. I'm making it as 1000 milliseconds. That is 1 second. Okay. Now, in this loop, I'm going to fetch the URL again and again every second. Okay. And I'm going to apply this condition based on the data I get from the server. Okay. Now, where is my server? How can I get a server? Right now, I can't get a server. So what I'll do is, yeah, now we need to move to the cloud. Okay. So I'm using a free account from Award Space. See, not all cloud hosting support IoT. Okay. I have a hosting account in Infinity Free, which doesn't support my IoT devices. So I'm using something called Award Space. Okay. I hope it is visible to you. Yes. Now, once you log in, it is free, of course, but it has some limitations. This will be your dashboard. So some people say cloud. How does it look? Nothing special actually. It looks like this. Okay, you have a dashboard and you can do whatever you want. Now there are some other platforms. Okay, I hope in day before yesterday's session, Amazon, you have seen, you have infrastructure as a service, platform as a service, and software as a service. Okay, there is Blink and ThinkSpeak who give you software as a service. Okay, that means you don't need to write the code on the server. Okay, if you don't want to write code on the server, you can go to Blink. Okay, you want some advanced data analytics, you can go to ThinkSpeak. Okay, so Blink is there. Blink, it's loading. Yeah, so this is Blink. Okay, which is software as a service for IoT devices. Or you want some data analytics, you have a lot of data, you can choose ThinkSpeak. It is loading. It has MATLAB analytics. Okay, good visuals. Okay, of course, if you pay, you get better services. You can use a free tier services also. Okay, so these are like software as a service. I hope you remember Amazon, Sirisha ma'am was discussing. So this is software as a service, Blink and ThinkSpeak. There are many more. I'll just stop it over here. Now I'm using something called platform as a service because I know how to code, and I want you to know how do people write the code in the server. Okay, so this is award space. This is my dashboard, and of course I have some limitations. I hope you can see. I have this is how cloud dashboard looks like. Some few dashboards look different. Okay, so this is the limitations. I'm getting 5 GB of traffic per month, and I get 1 GB of disk space, and I get some free subdomains, okay, or databases, okay, and some emails. Okay, now what do I do over here? So I'll be going with the domain manager. Okay, I'll click the domain manager, and you can create a domain. For example, here you'll have, so imagine that I have clicked this. So domain manager, then this will pop up. Here I create a free subdomain because domains are not free. So subdomains, some people give it free. So you can choose. I chose this one. You can choose any extension. I choose this one. So once you create it, it will be created and you can use it. Like this is mine, sujanavan.@webpages.com. Okay, just remember this. I'll tell you why. Okay. Now, once you get a subdomain, free subdomain, now what you need to do, I'll just show you the files. Okay, what files I have. Yeah, it is not secure, I know. This is a demo account. Okay. Yeah, security is not my concern. Integration of things is my concern. Security is people in security. You have to tell me how to be secure. Okay. So index, there's a file index, which is my landing page. Then there's something called sense, which is going to take the data from the user, front-end user, and post it to this file called data. Currently, yeah, this data is nothing. It is 0. Okay, let me just go back. Yeah. Now, what is in this index? Nothing special. I just write a welcome message, and this is a simple HTML file. I thought that it should be as simple as possible for beginners. Okay, so you just have 2 buttons and 2 forms. Submitting a value 1 if it is on, and value 0 if it is off. This is a very basic HTML which people know. Okay, 2 buttons, on and off. On will submit the value 1 to whom? Sense.php, and off will submit a value 0 to sense.php. Okay, now what will sense do? Sense won't do anything. Okay, it will just get the values from the users. Okay, it will just get the values from the users and write it to this file. Yes, you see, right? File. I open this file in write mode. Okay, this is in PHP, easy to learn server-side scripting language. Most of you already know it. Okay, and then you just write the content. You just write the content into data. Okay, you just write it to this file data. Okay, so currently this data is 0. Okay, now this data URL I'm going to borrow. Okay, this data I need. So let me just see. So I'll just copy this, and then I have to extend it by this file data. So let me just show you. So /data. Okay. Now, physically, as a human being, you are seeing this 0, right? You are physically seeing this 0, right? When you go to this URL, you are seeing 0, right? Same URL. Let me copy it. I'm copying this URL, and then let me go to this microcontroller, and I'm going to paste it over here. Okay, in the URL variable. Okay, I just paste it over here. Now, who is going to see this 0? The controller is going to see this 0. Okay, it is going to request for this data which is over there, okay, on the server, cloud server, and it is going to read it, the result. It's going to read the result of this HTTP, result of the HTTP. It's a 0. Okay, now if it is 0, what is going to happen? It is not going to glow. It is not going to glow, right? Yes or no? Now, how do I make it 1? So just go to my this URL, okay, and then if you click on, okay, then it will glow. Okay, so just click on, okay. Now what is going to happen in the data? Yes, right now it's not blinking, so just run it. Okay, so data is 1, that's why it is 1, right? So that's why it is glowing. Now I request the participants, just go to that URL. We'll see, just go to my URL. Okay, let me see who's active right now. So just go to this URL, sujanavan.activepages.com. Just share it to you here. I shared it in the chat. Okay, just go to sujanavan.activepages.com and click on and off. Let me see what's going to happen. Who are active? Let me see. I'll just see for 1 minute whether participants are using the link and switch. Yeah, someone has switched it off. Someone has switched it on. I don't know who. Yeah, parallel things create problems. Yeah, some parallel people are trying to switch it on and off. Yeah, once you switch it on and off, I hope you should be observing this LED. Okay, and you should know about this status. Yeah, this status, you should know about this status. This is a success. This is a success return. Okay, this is a code in HTTP which says it is a success. 200 is a success. 200, not 200. 200 series is a success. There are some conditions over it. Okay, very good. I guess participants are going to my URL. Great, great. Yeah, so zeros and one. Now I hope you understood. See, this is not a great Internet of Things, but I want the beginners to understand how the complete logic. So you have seen the code in the microcontroller, which is a physical thing. Of course, it is logical here in the Cisco packet tracer. And you have seen me going to the cloud. You have seen me going to the cloud. I am using platform as a service from Award Space. You can use Blink, you can use ThinkSpeak, you can use IBM, Watson, Bluemix, up to you. Google, you want to pay Microsoft, your wish. Okay, there are some free versions also, you can use trial versions. Okay, so I hope it is clear till here. Okay, so I don't want to use Blink because I don't know what kind of code they wrote. I don't want to use ThinkSpeak because I don't know what kind of code they wrote on the server. Okay, so I've completely explained, okay, step by step, okay, including the code. Okay, so it's okay. I'll just delete it because again my bandwidth goes off. I'll just stop it. Back to our presentation. Yeah, that code is not secure, of course, because all of you are. I want all of you to see the demo. That code is not secure. Okay, so I was using this Award Space. Okay, you can use whatever you want. Okay, so I just wanted to show you like the basic things. Okay, the most fundamental things, how things are happening. So here nothing is everything is transparent, which I have shown. I have not used any different service. Okay, the code you see is doing everything. Okay, there is nothing hidden from you, and that is the exact code which is running. Okay, so any doubts? Can I take any doubts here? Which let me tell you again, the doubt should be related to IoT, please. Okay, I'll just pause for a doubt. Pause for doubts. Coordinators, are there any doubts? From the YouTube live session, are there any doubts?
No, sir.
No, sir.
No doubts. I hope the concept is clear. I have shown, because there are first years over here, there are non-CSE students over here. So I hope you have understood the fundamental concept of IoT. Okay, do you have any doubts?
can turn on
Participants,
your
do you
mic
have
and
any
ask
doubts
any
in the
doubts.
YouTube live session?
Participants, if you have any doubts, you can turn on your mic.
Yeah, because after this, there are no more fundamentals. I'll be moving to the next floor. Okay. I'll go with the research areas. So this is
Yes, sir.
till where our
Please continue.
fundamentals go. Of course, at the end again. Yeah. Yeah. Okay, I'll continue. Okay. Yes. So I hope the concepts were very clear for you with the IoT. Okay. Basic fundamentals. Okay. Fundamentals, if are strong, you can do what wonders you want to do. But let me move on a different scope of IoT, or the level of IoT. Now, if you have multiple things talking to each other, okay, and doing some kind of computation, okay. For example, instead of bulb, there is a camera, okay, and there is one digital camera which is trying to do some image processing as a leaf node. Okay, now what kind of image processing it's doing, I don't know. Okay, that's up to the image processing team. Okay, so now that image processing done at the digital camera is a part of something called end computing. End end device computing. These are end devices. Let me tell you, these are end devices, and it is called end device computing. Okay, now if you integrate these end devices together, that's called something called as edge computing. So where does edge computing happen? It happens at this level. Okay, where it can integrate multiple end devices. That's end computing. Okay, now you have multiple edges. Okay, multiple edges. They come together, okay, onto a platform, like how end devices have come together onto a platform to exchange information. That's called end edge computing. Now edge computings come together on a platform which is called fog computing. Okay, now multiple fogs. Now fog computing happens at this level. I don't say ISP. I don't say it happens at ISP level. It happens to the next level of the edge computing devices. Now multiple fog computings come together, yeah, onto the platform of cloud computing. Okay, please understand how we are moving up. Okay, we are actually moving up. I'll show you. There's another chart. Nothing to worry. Okay, now multiple cloud computings, they also come together on a virtual world, a complete virtual world, which is called as sky computing. Okay, when I say sky, there's nothing, absolutely nothing. Okay, it's all APIs and how servers talk to each other, cloud talk to each other. Okay, so that is sky computing. Okay, so this is how it looks. Okay, so you have end devices, they collaborate, and that becomes edge computing, or edge devices computing. There are billions of them. Okay, then you have fog, they are called nodes, they are in millions. And of course you have your cloud, which is in thousands. And sky is nothing. Sky is really virtual. This is completely virtual. There's nothing. Sky is like clouds integrated. Okay, so frankly speaking, there are no servers also. Okay, yeah. Now why do you need this architecture? So that these billions of devices do not overload these thousands of devices. Okay, you don't want your heart rate to be sent every second to your cloud. Okay, of course heart rate is important. Of course, let me go with temperature. Okay, temperature is somewhat a better example. You don't want temperature, whether it changes or not, you don't want to post temperature to the server every time. Imagine number of end devices are there to just capture temperature in the weather. Okay, you don't want to disturb the cloud, right? So you will disturb the edge, which will disturb the fog. If there is any change, it will notify the fog. If fog finds any change, they will notify the cloud. Okay, for this I have another example, nothing to worry. So let's see that temperature example. So whatever computation happens in the microcontroller, it is a part of something called end device computing. Okay, now all the end devices, for example, they have captured temperature and they send it to the edge device. They send temperature to the edge device. So I have a small region. For example, imagine I'm in a area called Uppal. Okay, I get a temperature value of Uppal from Google. Okay, how does it come? Who is measuring it? So there are some nodes which are measuring that value. Okay, now they don't disturb the server directly. Okay, because every second you don't want to disturb the server. So you just submit it to your edge device. Okay, now edge device, it will compute the average. It will compute the average of all these, and if it finds a change only, it will submit it to the fog. Okay, please understand. Only if it finds a change, it will submit to the fog. Okay, or else they just keep the data with them. Okay, they have the data, every second data, they just keep it with them. They'll submit if the average changes, or they have some threshold value. If it changes, they're going to submit it to the fog. Okay, edge is also nowadays called as dew computing. Okay, some people are calling it as dew computing online. Okay, next we have fog computing. All these edges, imagine all the edges in the city, they give it to one fog node. Okay, or one city, or it could be a district or a complete state based on how you want to get your temperature values. So these edge devices submit it to the fog, who is the head of a city or a district or a state. Okay, now this fog, it will try to compute the average of the temperature which it gets from the edges. Now you want Hyderabad temperature. Okay, now it won't disturb the cloud if the average temperature doesn't change. Please understand. Okay, or there is a separate threshold. Okay, if it changes, then it will submit to the cloud. Yeah, so this is how it's going, right? Now what do you do in the cloud? In cloud, you do your data analytics, data science, do image processing, do whatever you want. Okay, and then what are you trying to do? Okay, because here you have a lot of resources. Now you can do wonders. Okay, now you do forecasting. Okay, this is where you compute. Okay, you have that power to compute the huge amounts of data. Okay, so then you can forecast. Very good. Now, what happens here is, if there is a complete cloud for temperature, there is actually you have temperature, air pressure, humidity, all together in a cloud. Okay, now you have some weather information from satellite imagery that is in a different cloud. There is earthquake data which is in a different. Okay, now if they don't come together, you cannot detect disasters. Okay, that's why people are coming together, integrating together. That is where your sky computing comes, where you get patterns. Okay, different patterns from different clouds, they come together. Okay, now you are able to get to know about disasters earlier. Okay, I hope I have the Umang app. Yes, most of you who have the Umang app, I hope you know you get a message, right? There is some, I don't know, is it a cyclone? It's a cyclone. Okay, coming near Bangladesh and West Bengal. Okay, that is how, if you integrate data in the clouds, various clouds, that is where you do something called sky computing. Okay, so this is how I can explain. This is one good example how I can explain. Okay, now if anyone has any doubts regard, please ask me. Yeah, anyone has any doubts? There is a question from Sujita ma'am, Dr. M. Sujita ma'am. How cloud computing is used for forecasting? Ma'am, very good question. You are absolutely good, but I guess it should be answered by data science people. Okay, see, our job is we are providing data. Okay, so data science people, their algorithms, IoT people, they throw it on others. Okay, we only give you data. Everyone talks about data. We are giving that data. We are proud to give you that data. Okay, we integrate the technology, we produce you the data, do whatever you want with the data. Okay, so I'm sorry, ma'am, I can't answer that question. I'm not a data science professional. I'm not a data science researcher. I'm really sorry. I should not answer that question. Any other questions, please? Any other questions, please? Do we have any other questions? Coordinators, do we have any other questions?
No, sir. No, sir.
No, sir.
Yeah, I guess the participants are kind of irritated with my no as an answer, because I have been into my research in IoT a little longer before I got my admission. In the beginning, I didn't know what was IoT, but now as a researcher, I want to give a perfect scope of what is IoT and what not is IoT. Okay, so cloud computing, we use cloud computing, but no, we don't go in detail. Okay, we use all the technologies. I hope the participants will agree with my answer. Okay, if you are a researcher in IoT also, please, I hope you understand that that is what IoT is. Okay, I'll continue with my presentation. Yeah, so next, so we are going to the next floor again. So one floor, one level up we have gone. Now we are going another level up. So what projects or what are the areas of research where you can what you can do in IoT? So these are very vague. Let me tell you, these are very vague. Okay, okay, so let's start. The first one is standardization itself. Okay, standardization itself is a research area where people are trying to create frameworks or technology and protocol stacks. Okay, some people say I will go with a standard. Some people say you need to use another standard. Okay, some people say LoRa. Okay, some people say no, I'll go with NG-IoT. Okay, now it's up to you based on your project which kind of standards or technology and protocol stack you need to use. Okay, don't think that if LoRa is a 10 kilometers range, I'll use LoRa. No, what is your requirement for your project? You think about it. Okay, and then you conclude. Okay, if you're doing a home automation project, why do you need LoRa? I don't need LoRa. Okay, so some other home automation project might need LoRa. Okay, I don't know. I'm telling that in one scope you don't use some standards. Okay, so there's a lot of research going on. That's why you have so many standards over here. Of course, LoRa, it came right in front of your eyes. Okay, most of the people, elders, they know that many things they have just come in front of your eyes. Like Zigbee came in front of our eyes. Okay, and Bluetooth versions, how it has advanced. Okay, it came right in front of our eyes. What about Wi-Fi? Wi-Fi also came in front of our eyes. Okay, WiMAX or some other technologies. Okay, so the standardization itself in IoT is becoming a challenge, and you have a lot of areas over here to work with. But this is on a higher ground. Higher ground in the sense, people who are opting for manufacturing or producing projects or solving business solutions. Okay, yeah, of course you can also work over here. Then comes system architecture. This is another big problem. Why is this problem coming? Because of standards. Because these many standards are there. Now some people say that I'll use one over here, one over here, one over here, one over here, and I'll make my own architecture. Combine these, make it an architecture. Okay, now Intel, Google, there's a platform. Yes, it has its own architecture. Now AWS gives its own architecture. IBM gives its own architecture. Yes, and of course We have Microsoft over here giving its own architecture for IoT. And there's a new player in the market. I hope you know, you got the news from Google. Samsung also is into the market and it gives its own architecture for IoT. Okay. And there are some people again who compare everything with the big people of IoT, and then they give their own architectures. Okay. Kind of open source architectures. Okay. So this is a problem actually. No one yet knows the exact architecture, what to use. There are many projects where you use a different architecture. For one project you might need one, another project you might need one, or in another project you might need across domains. Okay, so that is what is the problem in system architecture. Yeah. Next is the big headache, that is interoperability and integration. Now once you have a lot of standards and you have lot of system architectures, now you have manufacturers and vendors. Let me tell you, manufacturer is the actual person who is manufacturing it. Vendor is a person who is getting it manufactured. Okay. Now same product from two things. For example, Raspberry Pi and Orange Pi. Okay. This is one good example I can give. Okay.
Hello, good night.
An approximate example. Okay. So, yeah. So we have manufacturers and vendors, and again this is becoming a interoperability. Like things, you do coding on one thing or you work on one thing by one vendor and you move to another vendor, or you want to have a device from a different vendor. Now he gives his own architecture and standards. Okay. Now once you want vendors to come together, you need something called semantics, so that things can come together and integrate. Okay. Now everyone has their own semantics, they define their own semantics. And finally you need gateway support. Yes, finally, so that things can integrate well. Okay, different things can integrate well. You need the gateway support. So research, these are the research topics in interoperability and integration, because you have a lot of manufacturers and vendors in the market. Yeah. Next comes availability and reliability. This is where your connectivity comes, connectivity and the problem of mobility and routing. Okay. As I said, yeah, you want to run a drone, which kind of connectivity you need? You want to run, nowadays you're telling like automated car or automated driving cars. Okay. Which kind of connectivity you need? It's called critical IoT. Okay. And nowadays you have robots doing operation. Yes. Now, what kind of connectivity you need? You need seamless connectivity. Anything goes wrong in a microsecond, it's going to become a problem. So this is another area where you have connectivity, mobility, and routing, which could be your research. Means what to choose for a particular domain. Okay, it could be one research. So you compare like different connectivities and mobility schemes. Okay, and then you filter that for this project, for this particular project, it needs this kind of connectivity. This particular project needs this kind of connectivity, that you need to research by comparing. Okay. Anyway, people are building it. You need to do research on how it suits a particular project. Okay. Then comes data storage and processing. Yeah. This is where you have topics of computing, analysis, and visualization. Okay. So this was the earlier past ETL standard. Now it is becoming ingest and analyze standard. Okay. Again, there are different models given by different companies. Now, which will suit our IoT? Let me tell you, we are not developing it. Please understand, we are not developing it. Which will suit which project? That becomes your research. Okay. So that is in the area of data storage and processing. So this is another example which you already know. You have attended some sessions. So this is what happens to data. You sense raw data. That is what our IoT people do. That filters. This is, we just use some engines. We are not developing the engines. Please understand. We are choosing a particular engine to filter information. Then nowadays it's becoming something like feature recognition. It's becoming knowledge, and now you are sharing this knowledge. Please understand. You are sharing the knowledge. Okay. Very good. So this is into data storage and processing. Okay. And next you have scalability. Don't think scalability is a problem of the cloud. Of course, it is the problem of the cloud, but it's a problem everywhere. Okay. Even humans are growing. So what happens if there's a massive growth? How do you discover things? So this is a small graph from IoT Analytics, which was given in 2018. They predicted that by 2020, there will be 21 billion devices. Non-IoT and IoT together, there will be 21 billion devices. But Cisco, yeah. So Cisco in 2020, they have found out, before 2020 only, this is an old chart, they found out that there are 20 plus billion IoT devices itself. That is the scalability. You were thinking IoT and non-IoT together, now it becomes only IoT devices that become 20 billion. Okay. So that is the IoT units installed. Okay, this is from Cisco. Okay, the source is from Cisco. Right. So next, so that is a problem of scalability. How do you manage massive growth and how do you discover? So you have different discover mechanisms. Okay, so which suits you best for a particular project? That's the research. Okay, and how are you predicting massive growth? Which algorithms are suiting you? That becomes your research. I'm not telling you to create those algorithms. Okay, yeah. Next comes management and self-configuration. Please understand, something goes wrong in the IoT devices, you can't go running because there are billions of devices. So how do they self-repair? How do they self-manage? If I sell a product in the market, how does it automatically get added to my gateway? How does it get automatically added to the gateway? How can the gateway manage the device automatically? So this is another domain. Okay. Yeah. Next you have performance and QoS. Okay. Now let me tell you, performance and QoS both are called trade-offs. Trade-offs means you want performance, you need to sacrifice QoS. Okay. Computer network people know about it. So what should we choose? What kind of quality of service we choose? That is based on the performance. Okay. So you need to do research, like there are different QoS, okay, levels, okay, and for your project, which type of QoS is well suited? That is what you need to research on. Okay. Then the next problem is identification. A very huge problem, because I hope 1 decade back, 10 years ago, when I was doing my engineering, the problem was mobile phones, IMEI number, China mobile phones, sorry to say China, IMEI numbers of some mobile phones were copied, means cloned. Yes, so that becomes a problem of identification. Yes, yes or no? Yeah. So how do you solve the problem of identification? There are many schemes. I'm not telling you to invent a new scheme. I'm telling you what scheme is well suited. There are many schemes. What scheme is well suited for you? Okay. So you need to have some trusted party, or you have seen blockchain, right? Everyone saying blockchain is coming up. You can use blockchain over here, where you'll get certificates. Okay, nowadays browser itself, you open some other website, it will tell this certificate is not valid. Okay, now that should happen among so many billions of devices. Okay, certificate validation, whether it's from a trusted party or not, and everything. Okay, and you need a huge certificate inventory. Okay, who's going to maintain it? Okay, I guess this problem will be solved by blockchain. Okay, so this is one area. And next area where you do not have continuous power supply, we have the area of energy consumption. IoT devices which are running on batteries, they have a problem of energy. You need to manage that power. Okay, of course you have nowadays different harvesting techniques, but the problem, let me show you, is different. Okay, if someone says my IoT device uses very low battery, something like you give me a AAA battery, which is I don't know, 500 mAh or 700 mAh, and it will run for 10 years. You're claiming it will run for 10 years. Let me tell you something. Even battery will get rusted in that 10 years. Okay, please let me tell you something. So this is a small example where I've taken a tap, water flowing from the tap. Okay, now this is called energy harvesting. So this part, tap filling the bucket. Okay, this is what is energy harvesting. And please understand that this bucket is an iron bucket. It will rust. So battery is something which will die. Okay, whether you use it or not. Okay, it is going to die one day. 10 years down the line, some batteries 5 years, some batteries just in 2 years. Even your mobile phone batteries, you know well, right? First day of purchase, it runs for 5 days without charging. Okay, next month 4 days. Okay, you know well, you know better than me, right? Yeah. And what are the holes in the bucket? Holes in the bucket is the power consumption. Okay, power consumption is these holes in the bucket. Okay, then what is the battery capacity? Battery capacity is the capacity of this bucket. How much water can it hold? Okay, yeah. And then, yeah, if you have too much water flowing in and the bucket size is less, it's a problem. Too much water flowing in and too less water flowing out, again it is a overflow, it's a problem. Underflow, it's a problem. Okay, so bucket size and battery lifespan. Okay, rusting will happen even when the bucket is idle. Okay, please understand. Okay, so your battery will die one. Okay, so this entire thing is a research, means which battery should I use, which type of, I'm not telling you to invent a battery, please, which battery will suit. Okay, what will be the capacity of the battery, what will be the energy harvesting technique. You are not going to invent solar panels, you're just going to check which panel or which energy harvesting technique suits you. Okay, well, for a particular project, that becomes a research topic. Okay, next, someone asked security. Very good. Security is a very complicated issue in IoT. Some people say it doesn't belong to IoT, but nowadays they are saying that IoT people have to take up this job. Now IoT people say that you give us the security mechanism, computer networks people, you give us the security protocols, and we'll test it and see whether it is going to work well in IoT or not. Okay, so what is the problems in security? We have authentication, we have authorization, we have something called privacy and trust. Okay, so you build a huge system architecture for security for your projects and for your business, and finally one day, I hope you remember May 7th, what happened on May 7th, right? Yes, so they found out that after 8 years, means for 8 years, this fellow, he's a good fellow actually, because he didn't do anything except downloading some his favorite videos. Okay, so he was operating on a massive IoT botnet. Okay, see, so there was a loophole in some devices. Yes, it peaked in 2015, and see, you got the news in 2020. Okay, yeah. See, this is again a problem. Now you think that everything is secure, and later you get to know after some time. This is the problem with security. You don't know until and unless it comes out in security. Yeah. So we are not developing protocols here. Computer network people are doing it. You need to match which protocol runs on your IoT device. You can't take a hefty protocol and run it on a device which doesn't have the capability itself to run. What is going to happen? Something like, I want to run Windows 10 on a 1 GB RAM, a Pentium 4 computer. It will run, I can understand, but what will be the performance? Okay, so that is how you need to match your device and your protocols. Okay, and algorithms, security algorithms. We are not developing it, we are using it. Okay, which is best suited, we need to research on it. Okay, then comes environmental issues. Okay, now these are very difficult. Okay, so these, like, people who are going into manufacturing completely. Okay, they think about what will be the carbon footprint. Tomorrow people will use it and throw it. What will happen if it has lead, if it has mercury, if it has cadmium or chromium? What is going to happen? So people are trying to manufacture products which are free from all these toxic elements. Yes, and of course you have some standards you need to become compliant with, and the level of compliance. Okay, something like, are you 100% compliant or 80% compliant? This is a different domain. please let me tell you, this is a different domain, but let me tell you something, that you need to choose your equipment. You need to, when you choose your equipment, see that they satisfy basic environmental complaints. Okay, something like lead free, chromium free, ROHS complaint. Okay, of course, you know about FCC and CE. Okay, see that these complaints is there. What is the advantage if these complaints are there together? Okay, think about the environment. Of course, lockdown we have reduced pollution, but tomorrow again it will grow. Okay, so think. Yeah, so these are all the research areas we have seen, and these are all the research topics. These are all the research topics related to the areas at a single glance, which you can have. Okay, yeah. So next, we'll be moving to the horizontals and verticals of our IoT world. So I was discussing about the horizontals and verticals. So these are the verticals. So verticals are devices, embedded software which runs on this device. Okay, and then communication mechanism used to interact with your cloud or among each other devices. And what are the applications? So these are the verticals in our domain. What are the uh, horizontals in our domain? We have UX. Okay, see, UX is not our domain as CSC and IT. Let me tell you clearly, it is an arts domain, and it is about human psychology. Okay, of course, you can also get into it subtly. Then we have data. Then we have business. Of course, you want to get into business. This is a horizontal. Okay, then we have another horizontal, technology. That is where IT people are. Then we have security, and then you have standards and regulations. Okay, these are all the horizontals and verticals. So what was I discussing about? What did I discuss about? Where are we in this world of my discussion? Okay, so you are over here. Okay, you are in the technology side. Okay, you are on the, so we discussed this part. Okay, I discussed about the technology part. Okay, now what are the basic tools and technologies to start off right now? You have seen Cisco Packet Tracer, but if you are not a Cisco NetAcad student, so how do I do? So let me see some tools. So you can use, there's something called BabyWise. You can use the trial of it. Then you have Cup Carbon. These are all simulators. Cup Carbon is free. Then you have NetSim, OmniNet++. Okay, there is a operating system based on Ubuntu. It's a distribution called as Contiki OS, which has a Puja simulator. Okay, of course, we have our famous Network Simulator 3. Then you can also use Proteus. Okay, to check. It is also a simulator. It's also good. It's free. Okay, and yeah, if you don't know how to develop applications on Android, you can use MIT App Inventor. If you are working with PIs, that means small board computers or single board computers, you will be working with Python and Scratch. Scratch is a visual programming language. I'll just show it to you. Then there's something called Fritzing. Okay, it is also a designer, just a designer, and you have Arduino IDE where you are going to port your programs to your hardware. Okay, and what kind of hardware you are going to have? Of course, it could be a microcontroller or a processor. Then some sensors and actuator modules. Let me be clear. So you don't want to develop them, right? You don't want to. I get a sensor, and now you ask me, sir, what resistance should I add? Okay, that is up to ECE people. Okay, here I'm talking about CSE students and IT. So we get modules, everything is ready, and you just integrate it. Okay, yeah, and you think about power. Okay, now you have ARM based, you have Pi, Eagle board. Pi means Raspberry Pi, Orange Pi, Banana Pi. I don't know. Tomorrow Mango Pi also will come. Yeah, and then you have x86 architecture based. You have Intel Edison and Udo. Okay. Now these are microprocessors. Okay. Now you can also have microcontrollers. Okay, there are many, but nowadays Arduino based. Let me tell you, Arduino based, because Arduino is an open source hardware. Yes, it is an open source hardware platform. So many people are developing Arduino based products. Okay, and you can get some network shields. Okay, to get onto the internet side. or the networking side. Okay. So on the cloud side, you can use Blink. Yes, it is software as a service. All these are software as a service. Okay. Or you can use ThinkSpeak, where you have MATLAB data analytics. There's something called IoT-Fi. Yes, you can get free accounts over here. Then you have IBM Watson and Bluemix and MediaTek. I hope you know MediaTek is a very famous chipset company, manufacturing company. So they also have something called Cloud Sandbox, where you can get like one device free. Okay, one device free. Now this is for people who don't know how to code. I don't know how to code. This is your area. If you want to code on the server side, then you go to platform as a service or infrastructure as a service. And these are some free. Let me tell you, there are some free things, free. Okay. Freeware things or free trial things. Okay. You can write your own code. If you know how to write your own code, come to platform as a service. Okay. So currently, let me just give you a glance of how to do. We have already seen award space platform as a service, which I was using. Now you don't know how to code. Let me tell you something. You don't know how to code. You don't know how to code on the cloud side. You are taking this group, right? You are taking this group. You don't know how to code over here with the things. Then you take something called Circuito.io. So let me just show you. So this is Circuito.io. Okay, this is the website. Just go to app. Okay, you'll get an online interface. Okay, just agree to the terms. Okay, I don't buy over here. Okay, I just design over here if I don't know about something. So imagine you want to get a humidity and temperature sensor integrated with Arduino. Okay, I purchased this from the market and I don't know how to connect it to Arduino. So you just drag this from here and throw it over here. Okay, and it will show you all the connections. Okay, it will show you how to connect it. Okay, imagine I purchased this in the market. Now it will show you how to connect it to your Arduino board. Okay, not only that, it will also give you the code. It will also give you the code. What else do you need? Okay, you know how to code it over here, how to code on the cloud, not how to code. You get the code here and you get software as a service. You can integrate them. They'll give you how to integrate all the instructions, how to integrate. That's sufficient. Okay, so Circuit.io is very good. Okay, I don't purchase things here. Okay, but it is good for designing purpose. And there's a project guide if you want to use. Okay. Then this is BabyWise. You can we have discussed like it's a simulator. Okay, this is also good. Like you have seen Cisco Packet Tracer, right? It's a different kind of simulator. BabyWise is a different kind of simulator. And then Cup Carbon. Okay, he has very good tutorials. Cup Carbon is doing very good. You can simulate an entire smart city. Okay, they have very good tutorials. I hope you can see. They start with Hello World. Okay, so Cup Carbon is very good. It's free. Okay, so Cup Carbon is good. Okay, then you have Proteus. So before testing it on the hardware, or you don't have the hardware right now, you can use Proteus like Cisco Packet Tracer approximately. Okay, but a little bit of training you can get from YouTube videos, and then you can simulate your environment. There's an ultrasound sensor over here, right? So you can simulate your environment in Proteus also. Okay. Yeah, then this is MIT App Inventor. If you don't know how to create Android apps, okay, here even kids are creating apps very easy. It uses visual programming. I told you about Scratch, right? So it uses visual programming. So let me just show you. This is my projects. So this is small addition which you can create in just a minute. You can create it in a minute. Just drag and drop whatever you want from here onto the screen. Really, drag and drop. I want a label. Just drag and drop. Okay. Now, how do you program? On this right hand side you have blocks. Here right hand side corner you have blocks. Yeah, I'm reloading the session, just a second. Yeah, it will take some time to reload. Yeah, so this is my projects view. I'll just open one project which you have already seen. Okay, so this is blocks I was talking about. This is just drag and drop. and this is blocks. Click on the blocks, okay, and see, this is called visual programming. Whatever you want from here, want something related to control or something related to text box, what do? Very easy, you just drag it from here and just drop it over here. That's it, visual programming. Okay, this is good. Even kids and non-technical people are also able to do. I just wrote a small, I didn't write, sorry, I just made these blocks. So when you click button 1, then set label and text to text 1 plus text 2. Okay, so this is a small code to add 2 numbers. That's it, very easy. So blocks, and this is the designer for it. Okay, you can test it out. It's so easy, you just need to build. Okay, and then just click on provide QR code, or you can save the APK to your computer. Okay, or if there's an app called MIT App Inventor AI Companion, you can use it on your mobile phone and you can get it done. Okay, you can just build. Okay, APK, it will take some time, it will compile your code, it will take some time. Yeah, if you use Android Studio, let me tell you something, you need to learn a lot. I hope people who have done Android Studio, they agree. Okay, you need to do a lot of programming. Okay, here this is for people who don't want to get into that stuff. Okay, so very easy. So it will build. You just need to wait for some time. And Android Studio, if you want to run it on your laptops or machines, you need to have a lot of memory. Okay, yeah. So you'll get this code. You can scan this code. If you scan this code or you visit this link, you'll get this app. Okay, this addition app. How, like, it's so easy. Okay, so this is the solution if you want to build apps for interfacing with your devices or with your server. Okay, now the next thing is, how do you integrate? So if you want to integrate, there's a very huge popular software called as IFTTT. Many people might have used it without knowing it. It's called If This Then That. Very popular software. You can do many things with it, nothing to do with IoT. You can do many things with it, non-IoT things also. Something like you can create some applets and services, okay, where you can create like you get a Twitter comment from someone and your bulb at home glows. Okay, a comment from someone in some social network and your bulb at home glows, or someone comments and you get a notification on some other platform, integrating different things. That's called If This Then That. This is a very good platform. You can just go through one YouTube video. You can do many things with it. Okay, you can't imagine, they'll give you some demos with it. Okay, that is about If This Then That. So next, so yeah, that's about it. So you have simulators. You want to work at home, very good, you can sit home and work with the simulators. Okay, by that time you'll get to know how you can sort out your things. Okay, or you don't want to buy also, you can work with simulators. Okay, because I have like 10 Arduinos, not 10, less than 10 Arduinos, but for my research I need 100. Okay, so practically I'm doing some things, and theoretically, not theoretically, I'm simulating few. Practically I'm doing few, and through the simulator I'm doing few, and then I'm comparing. Something like I have 10, I'll get the results if 2 devices interact, 3 devices interact, 5 devices interact, and 8 devices interact. I have the data. Okay, now I'll get the simulator where I have 10, not 10, 50, 100, 200 devices. Okay, now I compare that data. Okay, I have the original data, how devices interact, and the simulated data, so that I can find the difference and map that difference, so that I can get a correct output of my research. Okay, so that's it. Okay, so why I'm stressing on free means I have a small publication with my guide, Professor Ramadevi ma'am. She's from CSE department of CBIT, Chaitanya Bharati Institute of Technology in Hyderabad. We published a paper. It is all about like an uncomplicated, simple IoT SaaS development for deploying do-it-yourself, DIY, it's do-it-yourself applications using HTTP protocol with zero investment. Like you don't need to invest anything. Okay. Of course, if you want to buy a component, you have to. That's why I said SaaS development. Okay. So this is a paper which talks about the comparison which we have been done with different platforms, how they support your IoT. Okay, and it has like some research results of which platforms are difficult, which platforms are easy, and everything. So you can go through this paper. Yeah. And any other doubts you can ask, and where to buy, because no one wants to go out. You can go with ThinkBits, Silverline, Robo.in, module143.com, Factory Forward. These are all some big sites. Okay, very big sites. Sometimes it's costly over there. Okay, but reliable. I use Calcutta Electronics, which is, and some other sites which I trust. Okay, I don't mean that you use it and it's about trust. Okay, I use Calcutta Electronics. Okay, for some components I get it somewhat at lesser prices, and of course you have our saviors, our very own friends, Amazon and Flipkart. Okay, so you have a lot of opportunities. Cisco says there's a huge world of opportunities in IoT. So my session is done. Thank you. I hope I have addressed right from the non-CSC students and CSC first year students to the research community. And thank you very much. Any doubts? I'm here to take. Thank you, one and all.
Participants who have doubt can unmute their mics and ask the doubts. And you can also find the video recording in the YouTube as well, along with the PPT in the description. As well as the mail ID of the speaker. So I assume that there is no more doubts from the participants. Now I request Ritvika to give vote of thanks to the speaker.
Okay. On behalf of CSI MVSR, I take this opportunity to propose vote of thanks to those who have directly and indirectly contributed for organizing this webinar on IoT. At the outset, I thank our speaker, Mr. Sujanavan sir. We are really enlightened with your knowledge and presence. Thank you, sir, for taking your valuable time. A special thanks to student coordinators and branch counselor for the support and coordination. Our heartfelt thanks to all the participants for active participation. With these warm words and a kind message, we move to end of today's webinar. Thank you.
I would like to thank all the participants who have been with us from the day one and made the event so successful. Once again, thanks to all the participants. You will be shortly mailed about the feedback form as well as the all the PPT in the drive link. Thank you. Thank you, everyone. And Sujanavan sir, it was a great session. Thanks for enlightenment. Thank you.
Harshit,
Sir.
Harshit. Yeah. What about that YouTube?
Sir, YouTube is currently with 100 views. Actually,
YouTube link.
yes, sir. We will be sending the YouTube link to all the participants, sir. We have already sent, as well as we will be uploading another.
Okay, and also send.
We'll also add the PPT in the
Okay.
description, sir. We'll add the PPT link in the description.
Yeah, I invited some guests, so they'll get it from YouTube, right? Yeah,
Yes,
the
sir.
YouTube will be there, right?
24/7 throughout till the channel exists. There will be YouTube recording, sir.
Thank you.
Thank you for your words, sir. Thank you, sir.